Alright, hi folks. In this video we're gonna go through a topic called parameter substitution. It's part of Bash scripting guide. Okay, so this video will be based on this document. Alright, let's start. First one is this. I'll just show you here. It's just there to make it less ambiguous where the variable expression is and where it's just a plain text. Okay, so let's say we got foo equals foo bar, and I guess well, foo1 equals foo bar 1, let's say. And then if you want to echo a string containing these two variables expanded, we enclose it with a quotation mark and then go foo is foo1. Well, if you look at this, can you see where this first variable expansion is actually trying to expand the variable that doesn't exist, right? So what do you expect if we get rid of the command line argument? What do you expect if we execute this? Just says foo bar 1 because this variable doesn't exist. So how do we fix this? It's as we have seen over here. This makes it less ambiguous, right? So we surround it by this. This. So what do you expect? This will be foo bar is foo bar 1, right? So that's alright. It says here, if you got minus here, if parameter is not set, use default. Okay, and this is a variant of this, but it has a colon. If it has a colon, it means ignore when the variable is equals to null. Okay, I'll explain what it means. Okay, so we got var1 equals to 1, var2 equals to 2, and var3 is not set. Okay, so I remind you, if parameter is set, then we use its original value. If it's not set, use the default or fall back to default. So here the var1 exists, so it's 1. var3 does not exist, right? So we fall back to var2. Okay, and look at here. Username just sorry. What I mean is there's no command called username. What I meant was who am I? Who am I? That's Logan, right? So here, because username variable does not exist, it will instead echo the value from the who am I command. Okay, so here re-echoes the result of who am I command because username is still unset, right? So in my case, I'll show you here. So echo you first. Let's say you want to echo username variable. Expand it. It's nothing. Okay. So what to expect if we do? Yeah, it will use the output from whoami command instead of the value from username, because username is not set, it's undefined. Okay, so it echoes logo. Okay, that's cool. Now it's saying parameter and default separated by minus is equal to the parameter separated by default with minus and also the colon. They're almost equivalent, but extra column makes a difference only when the parameter has been declared but is null. Okay, I told you this extra column means ignore null. I'll show you what it means. Okay. Okay. Alright, so in this case, if you do this, username 0 is set. What's the value? It's set as null. Okay. So it says here username 0 has been declared but is set to null. So what do you think this will do? As I said, colon is not there, so you do not ignore null. Okay. So in this case, this has a value which is null, so it will not echo anything. Okay. Now here, username 1 has not been declared. So can you see difference between setting a variable to null and a variable that is not declared? Those two are distinct. Okay, so what if it's not been declared? Then what do you think this will do? It will substitute it with the output of the whoami command. Okay, in my case Logan. Okay, here username 2 has been set to null, like here. So it says here username 2 has been declared but is set to null. What do you think this will do? Can you see there's a colon here? I told you when there's an extra colon, that means we ignore null. So in this case, we're saying we treat username 2 to have empty value. So instead we output Logan, for instance. Okay, here it will echo because there's a colon. Okay, so this just reinforces what we've been talking about. This means, can you guess what it means? It means the variable is set to null. Okay, so here variable has been declared but is set to null. If you just have minus, it will output nothing. Okay, but if there's a colon, we output 1. Why? Because variable has been set to null, and when there's a colon, we ignore null. Okay, we rely on the default value instead. Okay, if there's a colon and the variable is null, there's a difference. Okay, so we unset the variables and then say here a variable is no longer set, so we rely on the default, which is 2. If there is a colon, in this case variable is not null, so it makes no difference. So we say variable is not set, so we fall back on the default, which is 3. Okay, I'll just revise so you know what it means. Okay, you know the pattern here. Username 2 has been set to null. Because there is a extra colon, it means that we treat the value of null as being empty. So what's the consequence of that? it will output the output of the command who am I instead of null. Okay, so let me just, let's say we got this username 2 that will set it to null, and then username 2. Okay, so here we're setting the value of username 2 to null. There's an extra colon, so we ignore null. Okay, so we are treating this username 2 to be empty. So we fall back on the output of who am I instead, in this case Logan. Okay, so we expect this to output Logan. Okay, but if you set the username 2 to null again and get rid of the colon, then it will treat the value inside username 2 to be null, and that has something. You don't treat it as being empty. What do you think this will happen? Now we won't echo anything because it will try to echo null. Okay, I hope that's clear. So here it says the default parameter construct, which is we have here, finds use in providing missing command line arguments in script. So it means that if you forget to provide a value to a argument, it will fall back on the default values. So it will always be populated. So let's have a look at the example here. Okay, so it says default file name is called generic.data, and you want the file name variable to always have a value. Okay, this one means the first argument that you pass here, and it says here the default value of file name is generic.data. Okay, so it says here, if not otherwise specified, the following command block operates on the file generic.data. Okay, so if I try to echo file name, for example, what do you think will happen? Because I haven't provided any argument, it would fall back to its default, right? Generic.data. Okay, but if I provide a first argument, let's say what's an alternative file name? Non-generic.data, for example. What do you think will happen now? File name will be non-generic.data. Okay. See? Okay, so this is a way of making sure that all the variables have a value, even if it's not specified. Okay. So what's the second one? It says must specify how many disks, and if it's not the number of disks, if it's not specified as the first argument, then it will fall back on the error code. This is just an error code. So here you can say there's a global variable that signifies error code for no parameter. Maybe you can say 999 or something like that. Okay, so it says set this variable to the first command line parameter or to the error value if it's on set. Okay, if I don't set anything, and here if I say echo this, what do you think it will happen? Because I haven't provided the first parameter, so it will return the error code. Well, sorry. has to be like this. 999. That's the error code for no parameter. If I provide number of this, let's say 1000, then it will be 1000. Okay. So it's a way of providing missing command line arguments in scripts. So that's how it's used. Okay. Now, if you look at why there's an equal sign here, this is a new pattern. It's very intuitive why it's an equal sign, because if parameter is not set, then set it to default. So setting is it makes sense to set it and designate that using the equal sign, right? So let me show you here. Alright, so this is a way of both declaring the variable and setting it if the variable is not set. Okay, so here variable called var is not set, so you will set the value of the variable var to be ABC, but the second one, it has already been set in the previous line, so it will stay as ABC. So here's the var variable had already been set to ABC, so it did not change. Okay, so that could be useful. This one is designated as the plus sign, and you might guess that this is like a opposite to the minus sign. Okay, because it says here if the parameter is set, then use the alternate value, otherwise parameter is set to null. Okay, there's a relation here. The plus sign over here and the negative sign here, they are opposite. Okay, so let's have a look at this code example. Let's do it. Okay, here parameter 1 is not set, right? So it will be null, right? So it's saying it's null. Parameter 2 is set to null. Okay, so can you guess parameter 2 will be set to XYZ? Because here the null is being counted as having a value. Okay, parameter 3 is called 1 to 3. It's already been defined, so it will be, its value will be changed to XYZ. Okay, here it has an extra colon. I told you this rule. Okay, if there's an extra colon, you don't you ignore null as being having a value. Okay, so here parameter 4 is not set yet, so let me just have it. Okay, so parameter 4 is not set, so variable a has been set to null. Okay, here the parameter 5 is set to null, but you have extra colon here, so it's treated as being having no value. Okay, compared to here, so we say parameter 5 is not set, so it will equal to null. Okay, different result from here. Parameter 6 is set, so it will be replaced by XYZ. Okay, can you see what's going on? Okay, so this is what's going on. So I'll go through it one last time. Okay, here the parameter 1 is not set, so it's set to null. Here the parameter 2 is set to null, but there's no colon, so parameter 2 is counted as being having a value. So a is now equal to xyz. Parameter 3 is set. Its value is 1 to 3. So its value is replaced by xyz. Okay, this time we got a extra colon here. So we treat null as having no value. Okay, we ignore null. Okay, so parameter 4 is onset. So we return null. Okay, parameter 5 is value of null. So we ignore it. So we count it as having a no value. So it returns null. The last one, parameter 6 has a value of 1 to 3. So its value is replaced by xyz. Okay, everything here very intuitive, very logical. It's very easy to follow the logic, okay, because it's designated very appropriately, okay. It all makes sense. Here it says the parameter is set, then use it. Otherwise, print the error message and quit the script with exit status of 1. Okay, so let's have a look at this example. Okay, it says check some of the system's environmental variables. This is a good preventative maintenance measure. So if, for example, user variable is not set, then the machine will not recognize it. It means just quit. If any of these 4 variables is unset, then quit with exit status of 1. Okay, so this form over here is used to test whether the this variable exists, and if it is unset, then quit the script with exit status of 1. It doesn't specify the error message after the question mark, and it's preceded by this colon over here. It means test. Okay, this is same as true. So let's look at the manual page for true. It says do nothing successfully. Okay, there's a reason why this colon is here. Okay, I'll show you why. Because without the colon over here, for some reason it will try to execute or try to treat the values of these variables as a command and try to execute it. And this true prevents that. Okay, so it says here name of the machine is the host name, you are user, your home directory is home, your mail inbox is located in mail. It says if you are reading this message, critical environment variables have been set. So this is it says good preventative maintenance measure. Okay, so you will only see this message if these 4 variables are set. Otherwise the script will quit with non-zero status. Okay, and okay, so yeah, so here this construct can check for variables set within the script. So so here it also begins with the true, and it's just checking whether this variable has been set, and it is set. Okay, so it will continue. Here it's saying this dummy variable has not been set, and this time you specify the error message. Okay, and it's saying you can also, if you have a to make it work, I told you it has to be like a like this. Otherwise the script would treat this as a command and try to execute it. Okay, but you can also do dummy variable it will give you the same effect, okay? Or even with the error message, this dummy is wrong or something, it will also do the same thing. Or you can even do this, okay? So what does this last one do? You will try to echo the error message from trying to execute this variable. Well, it's not a variable, I think it treats it as a string or something, but anyway, you are redirecting. Well, I guess you have to do it like maybe like this or something, but anyway, it's redirecting all the error message to device null, so it won't print it to the terminal, okay? So you say here, you will not see this message because script already terminated. Where? The script has been terminated here, or if assuming that this part has been successful, okay? So here it will not exit here because it's already exited before that. Okay, and it says in fact the script will return an exit status of 1. That's just by the definition of this construct. It says it will abort the script with an exit status of 1. Okay. Let me just. Alright. Let me go to my test. I will try to. How should I name the script? Okay, so I'll just copy and paste. Okay, here we will check whether either, well, all of these variables, is it unset or set, and if any of them are unset, then it will the script will be exited, okay? So let me just check whether we do have these. Hostname exists, user exists, home exists. I don't think mail exists, okay? So what do you expect will happen? It will quit, okay? So let me just, sorry. Ooh. What the hell is happening? Oops. Okay, I didn't. I did the wrong command. See here? It says the mail parameter not set. I think this is pretty useful because the error message is quite descriptive. Okay. If I set here mail equals no mail, what do you think will happen now? Sorry. Now mail is set, so this friendly message will be echoed, right? Let's do it. See, look, your name of the machine is Logan main PC. You are Logan. Your home directory is home/Logan. Your mail inbox is located in no mail. It says if you are reading this message, critical environment variables have been set. So it makes sure critical environment variables have been set, and if any one of them are missing or unset, then gives off a descriptive error message. and quit the script with non-zero status. Okay, so that's pretty cool. So have a look at this example now. Okay, yeah, so this is one of the ways this construct can be used. So you're saying if the first command line argument has been unset, then quit with the usage text. Like if you're writing a command line tool, this checks for whether all the command line arguments have been supplied by the user. Otherwise, quit the script and provide a help message. Okay, so here script exists here if command line parameter is absent with the following error message. Okay, this is the error message. So this is another way this construct can be useful. It says there are two lines. These two lines will echo only if the command line parameter is given, because if it's not given, then it will quit here. Okay, and it says here just echoing the value of the parameter. Okay, it says here exit 0 means everything's normal, and it will exist as normal only if the command line parameter is present. Okay, if you check the exit status, which is given by this $sign followed by question mark, if the parameter argument is given here, the error code will be 0. If not, it will be 1. Okay, let me use the script. See here, gives you the helpful error message. And if I do here, if I provide the command line argument, see, look, these two lines echo only if command line parameter was given, and it gives you the name of the content of the variable, the command line argument. Okay, so that's one way you can use it. Just saying, if you do this, it will return the length of this. If this variable has been expanded, this gives you the length of that string. Okay, and it's saying either this or this gives you the number of positional parameters. So if you have something like that, then you have 2 positional parameters. Okay, if you have either this or this, it will give you the number of elements in the array. Okay, this is another example we'll go through. Just specifying an error code for no arguments, and this just gives you number of positional arguments. As far as I know, it's same as this and that. Just gives you the total number of positional parameters for the arguments. Okay, and if no arguments were passed, then exit with exit code 65 and also provide a descriptive error message. Please invoke this script with one or more command line arguments and then quit. Right? So it's a dummy variable called var01, which has some value, and this will just expand the content of variable 1. This gives you the length. Okay, variable 2 has 1 space, and it will just give you the content. And it's saying even if there's a space, it counts as part of the length. Okay, and these two just give you number of positional arguments. Okay, so let me just execute. Okay, so as expected, if the length of the variable is 12, if you embed a space, length of this variable string will be one more, right? And it's 13 as expected, and we passed 2 positional arguments, so there's 2 here. Okay, so that's how you get the length of a variable. So well, these deal with length of the variable, these deal with number of positional parameters, and we could also use these to return the number of elements in the array. Okay. Okay. These methods deal with extracting a substring from a string. Okay. The first one, remove the variable string. Sorry, I'll start again. Remove the string. Remove from the string the shortest part of pattern that matches the front end of the variable. Well, sorry, the string. Sorry, let me say it again. This one removes from the string shortest part of the pattern that matches the front end of the string. If you have extra is it hash or something, then remove from the string the longest part of pattern that matches the front end of the string. Okay, with example it will be clear. Okay, it says it's stripped leading 0 from the argument passed. So this is a function. So what this is, in this time, number 1 does not refer to the command line argument. It refers to an argument that passed when this function was invoked. Okay, it's a parameter of this function, the first one, and it's saying from the beginning of that string, which is passed as the first parameter, remove well, in this current form it will remove 1 0 from the front of the string. Okay, let me show you. Okay, let's do it. Sorry, what will be? Let's pass this along. Let's pass this along as the argument. Yeah, and let's set it's setting the value of the variable called return, so we can get the value from there. Okay. Yeah, so here it removed 1 0 from the front. Okay. Before we get to the next part, how do we remove all the trailing zeros? Well, not trailing, I mean leading zeros. So we have to use a glove, something like this. Okay, this is a wildcard. Well, sorry, you need to change extra hash. Yeah, now all the zeros are gone. okay, from the front. Okay, but this will also work if I add like 0 here like this. Okay, well, let's see. Well, you'll get rid of everything over here. Okay, so it's not what you want, right? To do what you want, what I mean is how to just get rid of the leading zeros and not the zeros inside here. You need to use what's called a extended globe, and this is how you turn it on. Otherwise you can't use it. Okay, so let me, okay, sorry. Yep, let me turn on external extended globe, and then this is turning off extended globe after you use it. Why turn it off? Because it will interfere with other commands that you might want to use. Okay, so here we turned on external extended globe. Here we turned it off. So we are using a new syntax. This is a extended globe syntax, and we expect just these 4 leading zeros to be removed. Okay, see, so that's how you do it. This is another example. Okay, let me echo this environment variable. It just gives me my current location. If I do base name, just gives you this part. Okay, that's what we got here. And then from the front, so we got the pwd variable expanded, and it's saying from the front, get rid of this part. So it gives you the same echo. I mean, sorry, it gives you the same output as the base name command. Okay, so this $0 just gives you the name of this current script. It's saying all these 3 gives you the same thing. So let's just have a look at this one. Again, let me just, okay, let's say my script equals blah blah, something like that. Okay, and then we do here I'm just saying this 0 over here is same as this. Okay, name of the current script. Right, so let me have a look. Is this correct? So we've set the value to the my script as this, and we are saying from my script get rid of this portion. Okay, let's see. Okay, that's what it says. Lastly, it set the value of the file name to test.data, and it's saying get rid of everything up to the dot. So it will just give you the extension, okay, which is data. Okay, data. Cool. Here it's the same as this, but this time percentage means you will remove it from the front, from the back. Okay, not the front. So it has the same effect whether if there's a single percent sign or the double. Okay, it's analogous to here. Let me just go through this example. Okay, you set the value of the variable 1 as this, and you set the pattern. Means you'll start from A and end with C. So just echoes the variable 1 expanded. Just does the same. Just gives you the number of characters. You remember the syntax. And then here pattern 1 is A to C, and there's a single hash. Okay, so what do you expect? It will match just these first 3 characters and remove and then remove it. Okay, and if there's a double hash with the same pattern, you will match from A up to all the way up to last occurrence of C. So it will give you just the last 4 digits. Okay, here the second pattern is start from B up to 9. If there's this time we match from the end of the string. Okay, if it's the shortest match, like over here, then we go from the end and match from B to 9, like this. Okay, if there's a double, it means it's the longest match from B to 9 from the front, from the back. So what do you expect? We get from B to 9, right? So you only got A. Okay, so I'm saying the hash and double hash work from the left end or the beginning of the string, and the percentage sign works from the end of the string or the right end. I'll just I'll demonstrate over here. Okay, we work from variable 1. Let's get rid of the first 3 letters. Okay, so we do, well, the hash means start from the beginning. Okay, match from the beginning, and the single hash means shortest match. So we want A to C, right? You see ABC is gone, but what if one longest match? What do you expect? Then we expect from A to all the way up to C here. Okay, so that's what it is. Cool. We do variable 2, sorry, just the variable 1. Let's work from the end of the string, shortest match from the end of the string, and what's the pattern to B to 9? Okay, so B to 9, the shortest match starting from the end of the string that matches B and then some characters and then the 9. So we get rid of this portion over here. Yeah. Yeah, so this part is gone. If you want the longest match, we just double it from the end, 8 to 9. So we expect all of this to be gone. Just left with A. Okay, cool. This is a very cool example. It's a use case of the syntax, which is always welcome. So here, from the command line, you do the name of the script, which is RFE, followed by old extension and followed by new extension. So it's an example to rename all GIF files in working directly to JPG. Pass the name of the script followed by GIF space and then JPG. This is just usual practice, just give you a non-zero status for bad arguments. Okay, so it's here. This just gives you the number of positional parameters. If the parameter is not mentioned at all when you run it, or if there's only one parameter, then echo descriptive usage help and then exit with status 65. Okay, after that check, this one looks for all files with extension, in this case GIF, and assign that string value to a variable called file name. Okay, the file name is populated per iteration. Okay, so file name in effect gets the each file with the extension GIF or GIF. Okay, so this is a loop. So it moves the GIF file name, or sorry, the GIF file, and move it to the file name, the same file name ending with JPG. Why? Because this part over here, it removes the extension from the original file name and then replace it with JPG. Okay, so this is a very cool example. Let me demonstrate. Yeah, so I'm just saying this file name variable gets set per iteration of the for loop to be each file with extension GIF. Okay, so first iteration, if there's a match, the file name will be set to the first GIF file that you found from the working directory. Second iteration, it will be the second GIF file, and so on. Let me just say old file equals, I don't know, okay, Paris.gif, and then see, sorry, like this. See what's happening here? I'm just saying what's happening. Okay, this substitution over here, it from the end of the string get rid of GIF, so we are left with this part, and then append to it JPG, so the extension is changed. Okay, and we're using the move command, so we're basically changing the name of the extension of the file, all the match files. Okay, let me really see if it works. Just okay, so where does this work? Just a second. How do I? Nope. Let me just. Okay. Doesn't seem to work. Sorry, let me just array all. Alright, seem to. Oh yeah, we can use this. Okay, let's try. Okay. Okay. Okay, so here if it works means for each of these GIF files, GIF file names, we assign file name to be one of these, and each iteration we go through all of these in a list, and then here we here we use the same trick, right? From this, for example, in the first iteration, we from the end we remove GIF, so we end up with this, and then at the end we attach a new extension JPG. Okay, so what do we expect to happen here? We expect something like this. Okay, so let's try it. Yep, and you see the extension has changed. Okay. That's cool. Here is another trick to get a substring, okay, from a string. So this is just specifying an offset, okay. This is a specifying an offset as well as the substring length, okay. This is just a replacing what's matched by the pattern with the replacement string, and if you double the slash, becomes global replacement, okay. Let's just have a look at this example over here. Okay, so here we set the variable 1 as this random string, and then we got a substring from it using this substitution. This hash means start the match from the beginning, and the single hash means the shortest match is removed, okay. Here the pattern is wildcard minus wildcard. This is not as you would expect. What will happen is this will start from the beginning, and then match here, match right up to here, okay. You might have expected instead we will match this, but it says here you will match everything preceding, including an empty string. Okay, so I guess this second wildcard is interpreted in this context to be empty. Okay, so what it means, it will only match up to here. Okay, but you could also do the same with this, and this is less ambiguous. Okay, here double hash means the longest match from the beginning. What do you expect? It will match everything. Okay, so it will be empty string. Now we got percentage sign, so it means you're working from the back, and single percentage means the shortest match from the back. Here you also be like this for the same reason as above. Okay, and let me just check that. Yeah, so the variable 1 ABCD minus is gone, and the second one minus DFG is gone. So yeah, now we set a path name to this path string, and then we are using this substitution over here. Double hash means start from the front and get the longest match. The pattern is slash wildcard slash, so you'll get rid of this part, so it will be a base name, I guess. Now we're starting from the end of the string and get the shortest part, and the pattern is wildcard dot wildcard. So I guess sorry, the pattern is slash wildcard dot wildcard. So I guess it will be this gone. It will be left with this. Okay. Let me. Yeah. So the first one you're left with. Yeah, you're left with the base name. The second one, the path without the base name. So we're correct. Okay. Now we are using the offset syntax. This means from this string over here, get rid of first 11 characters. Okay? So that's 1, 2, 2, 3, 2, 3, 4, 5, 6, 7, 8, 10, 11. I guess it's this one. And this one specifies both offset and the length. So from here you get 2, 3, 4, 5. So ideas, I guess. Let me just yeah. So this one is the first 11 characters stripped off, and from here, if you have a length, that's just ideas. So that's correct. Now we do replacement. Right. So here from the path name string, we are replacing Bozo with clown. Here we are deleting today with nothing. Sorry, let me say it again. We are replacing today with nothing. So we're deleting today. Here we're converting the lowercase o to an uppercase O. And here we are replacing the O with nothing. So we're deleting letter O's. Alright? And well, the difference from the first two and the last two is that this is a local match. It will just, I guess it will replace the first match only, and it will delete the first match. But here the double slash means the effect of the replacement is global. So here all lowercase o will be replaced by uppercase O, and here all occurrences of the lowercase o will be deleted. Okay, so let's have a look at here. So this is the path name. It says Bozo replaced by clown. There's only one Bozo in this case, so we are lucky. And here today is deleted, where there's only one today, so we are lucky again. And here all the lowercase o capitalized, that's what it is. And all the occurrences of o deleted, and that's what it is. So the first two pattern is only local, but we only had one match, so we were lucky. The last two are global. Okay, excellent. We're nearly there. Here the pattern is matched from well, let me see. So what it means, this pattern this is like in a regex syntax like this. Okay, you're looking at whether the prefix of the variable matches the pattern, and then substitute with the replacement. Okay, and this one, you're looking at the suffix of the variable that matches the pattern, and substitute, if it matches, substitute replacement for pattern. So I guess this is equal to like this. Okay, in regex. Alright, let's have a look at the example. Okay, so we got some value for the first variable. Match act prefix of the string. So from the front, we are matching ABC. So we got, and this is just, well, how do we, well, yeah, this is the thing. There's no global replacement here because we're only looking at the prefix or the suffix. Okay, so this one matches ABC at the front, so we are replacing this with this whole thing over here. Okay, now we are matched as the suffix. We got ABC over here, and we were replacing it with this. Okay, now if there's no matches, well, if there's no match, then replacement doesn't exist, doesn't get replaced. Okay, it doesn't replacement is not performed. Here the original variable try to match 1 to 3 at the front, but it begins with ABC, so the value doesn't change. Okay, and here it doesn't start, well, it doesn't end with 1 to 3 either, so no replacement occurs there. Okay, so let me execute. So if this is the original string, this one, it matches from the prefix ABC. Okay, right. Oh. Okay, so it replaces this part with this. Okay, and here we are matching at the suffix. There's ABC over here, so we replace it with this part. Okay, and the third attempt results in no replacement because it tries to look for 1 to 3 at the prefix, but it begins with ABC, so no replacement. Lastly, it tries to look for 1 to 3 at the suffix, but there's no 1 to 3 here, so no replacement occurs. Lastly, these two are equivalent. Okay, it matches the names, not the value, but the names of all previously declared variables beginning with variable prefix. Okay, have a look. So we set the first variable to be whatever, second variable to be null, and we're looking for variable names that start with X, Y, Z. So we got these two. Okay, and if you use this syntax, it's the same. Okay, now we define the second variable as something else. We look for variable name that starts with ABC, which is just this one, the one that we just defined. And this part is, it's like a pointer. What it does, it will look at the value of variable B, which points to this variable over here, and C gets populated with the value of that matched variable, which is something else. Okay, so C is equal to something else. Let me end with clarification over here. So we're saying over here B equals to this variable name, okay? But then C is equal to the expansion of variable B. That's what it means by this syntax, okay? And of course, if you expand variable B, what I mean is so let me start again. Variable C works like this. It will refer to variable B, and that's ABC23, and then we end up with expansion of variable ABC23, which is something else. Okay, let me check. Yes, so C is equal to reference to variable B, which is a reference to variable ABC23, and it gets replaced with the expansion of the variable ABC23. Okay, thank you very much.